three forces P, Q and R acting on a particle are in equilibrium and the angle between P and Q is double the angle between P and R, then show that R square equals Q within the bracket Q minus P or Q square minus PQ. Since the forces are in equilibrium, so the best way of tackling this question will be a Lami's theorem. And we know about Lami's theorem that if three forces acting at a point be in equilibrium, then each force is proportional to the sine of angle between the other two forces. So why not to solve this? The angle between P and Q, if I take the angle between P and Q to be, say, is double. So if I take this as, this is P and this is Q and this is R. So if this angle is theta, then this is 2 theta. And this angle between P and this angle between Q and R will be 360 degrees minus 3 theta. So now applying the Lami's theorem. So Q upon sine theta equals R upon sine 2 theta equals P upon sine 2 pi minus 3 theta. So if I take radians, then these angles will be in radians, or we can take this in degrees too, and that is not a problem. So you could take this as, if we have taken everything in degrees, so please consider this as 360 degrees. Now what is sine 360 minus theta? That is minus sine theta. Sine 360 degrees minus alpha is minus sine alpha. So coming back to the original question, so this is now we'll be expanding sine 2 theta as well as sine 3 theta. So we get dividing by sine theta in the denominator in all, or multiplying with, because it's a ratio, or multiplying with sine theta. So we get and I have also opened the bracket. Now by taking first two members, because there is a need to get to R, we get, by taking these first two members, we get Q equals R 2 cos theta. So with that, R is coming 2Q cos theta, and we do squaring because we need R square. So this is one relation which we have got. So I'm taking this relation as star. Now also from other two members, because again it is very important to connect Q and P. So now I'm taking first and third. So by taking first and third, so we'll now connect Q with P. So we get Q is equal to P upon 4 sine square theta minus 3. Since we have to get the answer which is free from trigonometry, so we need to be a little smart. We do the cross multiplication. So we open sine square theta as 1 minus cos square theta minus 3, 4 outside. We open the bracket. And we get 4 cos square theta. So I'm taking this as this equation as double star. Now please put 4 cos square theta. If you remember now what is a star, so we already have R squared is equal to 4 Q square cos square theta. So straight away we can put the value of 4 cos square theta here, which is Q square. And you can see that by taking the LCM, we are easily reaching the answer. This q and 1 power is gone. So this is the proof. Since these questions come for MCQs, so this is the basic learning. So you can even make it faster by skipping few steps. Thank you very much.